Great day, everyone. Today we are going to see Cambridge 9709 Mathematics PM1, which is differentiation. In the differentiation, we are going to see instead of chain rule. So, what is this instead of chain rule? So, in this video, we are going to see that how we are going to solve the problem without using the chain rule. Actually, we cannot say that it is not a chain rule. How we are going to deal instead of dealing with chain rule. So for example, how we will do a problem with a chain rule, we will be introducing a function, we will be substituting it, we will be introducing another variable. So instead of finding dy by dx, we'll be finding dy by dt and dt by dx. Then that we will be mixing up. Finally, we'll be getting that answer. So instead of that, how we have to find out the answer? So let's consider an example. Here, dy is equals to 4x plus 2 the whole cube. So this is a function and we have to find out what is dy by dx is. So how it is differ from the normal function instead of using normal differentiation method, how it differs, and then why we have to use chain rule and why we have to go with that another method instead of chain rule. So here if you see 4x plus 2 is a function and it's actually a whole cube. 4x plus 2, the whole cube is the function. Normally how we will be differentiating it, if it is anything like x power 7 or x power 3, so we will be differentiating and write this as 7x power 6 or 3x squared. But here it's a bit different. Either we have to differentiate the whole thing, because 4x has, it is actually only one 4x. Now when we are differentiating it is only will be getting 4, but a cube is also there, so you might get confused, or sometimes you will be writing only 4 power 3 and you will be getting that answer. Actually that is wrong. So what we have to do, you have to remember one of the concept what you have learned in IGCSE, that is changing subject of the formula. So for that you will be moving one by one. If you are having any equation this like a 4y equals to 4x plus 2 whole power 3, then to change the subject as x, what you will be doing, first you will be moving one by one, which is closely attached, that will be moving to that side. So cube will go that side first. Either you will be moving plus 2 or a cube, now you will be saying that cube only. So like that you have to consider. So what is the first operation or the last layer of operation is, until that you have to consider this as a box. So it's just a box power 3, anything to the power 3. If you are differentiating, what you will be getting, so that is what you have to write here. So it will be like, so directly you can write with the dy by dx equals to, so what is that, 3, because we know that x power n, if you are differentiating, you'll be getting n into x power n minus 1. This is what you'll be getting when you are differentiating this x power n as. So something to the power 3 is there. When you are differentiating, that 3 will come as coefficient, and what is left over that will come. So this we are considering as box. You just write that value, what is it in the box. So it's just 4x plus 2. The whole thing will be coming. Then what else we have to do? The power we have to reduce by 1, so it will become 2. You can still think this as a box. Then after that, what we have to do, whether our work is over or not. No, our work is not yet over. Then what else we have to do after that? Now you have to open this box now, which means the value which is inside the box, that you have to differentiate it. You don't need to worry about what is the power or what is the coefficient, anything. Just you have to differentiate only the value which is inside the box. Now 4x plus 2, if you are differentiating, you will be getting 4 into x, that is actually 4 you will be getting. Then plus 2, when you are differentiating, it's a constant. You will be writing it as 4 plus 0, but we no need to write that as 4 plus 0. We can write only 4, because 4x plus 2, when you are differentiating, will be getting only 4. Now what we have to do, so just simplify and write your answer. 3 into 4, because this is also a coefficient and this is also coefficient, so that too we can multiply. 12 into 4x plus 2 the whole square is the differentiated value, and it's over. Let's see one more example and let's try to solve that and check how it is easier than the chain rule. Now let's consider that another function, that y equals 6x minus 3x square power 10. So this is what we have to differentiate. So how are we going to do? Yes, here we have one value, then I mean the power is 10. So one function, normal function, that we know that how we have to differentiate 6x minus 3x. So it's very simple, but it is having the power as 10. So how are we going to differentiate it? So let's consider as usual. Let's consider this as box. So what are we going to do? We are going to differentiate. It is going to be dy by dx is equals to, first what did I say? So you just consider this as a box power 10, anything to the power 10. If you are differentiating, then x power n, when you are differentiating, you will be getting that answer n into x power n minus 1. So 10 into the value, what is left with the box, that is whole thing will be writing it as 6x minus 3x square power, where it will be 9 because we have to reduce it. So still you can consider this box is not yet opened. Then after that, what we have to do, as I said before in the previous example, you have to open the box, which means you have to differentiate that value which is inside. So 6x, if you are differentiating, will be getting 6 minus 3x square. If you are differentiating, it's going to be 6x, because 3x square, when we are differentiating, we'll be getting 3 2s or 6x. We know that. So we'll be getting that answer as 6 minus 6x. And maybe to write the simplest form, what you can do here, you can't take anything out because it has power 9, but here you can take 6 as common. In this you can take 6 outside. So what will happen, this will become 1 minus x, it will be. So this 6 can be multiplied with 10, so that you'll be getting the answer as 10 into 6, 60 into 6x minus 3x square power 9 into 1 minus x. So this is what actually we are getting after differentiating. Let's see one more differentiation example, maybe with another function. Instead of having the power as a whole number, let's try something. So here is our next problem, that y equals to square root of x square plus 3. So in the previous two examples, we have seen that the power as a whole number, but now we have as a fraction, because we know that square root of x square plus 3, that is nothing but y equals x square plus 3 power 1 by 2, because this is the easiest way to differentiate it. We can write like this. So what we are going to do, even here we have to consider the box as x square plus 3, and we know very well how we have to differentiate the value which is inside the box. Let's differentiate which is outside. So what are we going to do here? It's dy by dx is equals, first what will come, the coefficient, power will come as coefficient, it's going to be 1 by 2, and the value of the box will come x square plus 3 power 1 by 2 minus 1, it's going to be minus 1 by 2. Then whether work is over? No, not yet, because we have to open the box now. If you are going to open the box, which means if you are differentiating, don't forget to differentiate, don't write the same value. So we have to differentiate x square plus 3. If you are going to differentiate, it's going to be 2x. 3 will become 0, so that we can skip. So x square differentiated value is 2x, 3 is 0, so I'm just writing only 2x. Now what I can do, I have to simplify and write my answer. How am I going to simplify it? First I can simplify this 2 and then this 2. Then can I multiply this x with inside x square? No, because it is with the power and also it's a negative. I cannot leave that answer and like the same, because whenever we are giving the answer, it should be with a positive power. That's what actually a right way we will be giving. So we will be move this whole value, which value, the whole value of this will be moved to the denominator, so that we know a power minus m will give that 1 by a power m, which means when we are moving this value to the denominator, it will become positive. So this will become x square plus 3 power plus 1 by 2. Then what else is remaining? Only that x is remaining in the numerator, so that will come here. So may I leave like this itself? I can leave, but still I can write this answer as x divided by power 1 by 2. Now I know that that is nothing but square root. So square root of x square plus 3, I can write it. Have I finished? Yes, I have completed. It is the differentiated value. Instead of writing dy by dx, you can even write it as wide as that, you know. So that's it. We have differentiated. If you want, you can just have a look at it once again. So it's a square root of, cube root of, fourth root of, whatever they can give, that we can write it as the function's power 1 by 2 if it is square root, it's 1 by 3 if it's a cubic root. So like that we can write it, and by using the basic differentiation rule, we can bring the power as coefficient and reduce the power for the whole box, then again differentiate the box. If anything can be cancelled or simplified, just do it. Then since it is with a negative power, we will move that value to the denominator. Then that's it. Then power 1 by 2, again we can bring it to its normal form, that's a square root. So yet we have finished it here. So if you have any doubts on this, comment, we will solve it about the particular problem also. Thank you. Bye, take care.